Hello class, welcome to today's lesson. We are still on topic, or better well, subtopic 1.2, which is arithmetic sequences, also known as arithmetic progressions. I'm going to be telling you of these two words often so that you don't think that they are different. These two things are exactly the same thing. So this is the part 2 of this subtopic. And in this part, we're going to get to look at the series of a sequence. And also we're going to discover a formula to get the series of a sequence. So the series of a sequence and how to get a formula that allows me to calculate the series of a sequence very quickly. So what is the series of a sequence, guys? What is a series? It's the following. I have 4 examples here for you. So let's look at this sequence. This is a finite sequence because it ends. Okay, it's a finite number of terms. It has a finite number of terms. And the series of this sequence is the following. It's usually represented by an S, usually, although every now and then you can see this other symbol, this Greek letter. Whether you see one or the other, they mean exactly the same. For this course, though, I'm going to use S most of the times. So the series of a sequence, guys, is nothing other than the sum of its terms. Okay, in the sequence we have 4 terms, and the series of this sequence is simply the sum of all its terms, which in this case would be 20. If you sum these 4 terms, you will get this. So this is the series for this sequence. The series happens to be 20. It's that simple, guys. Second example, we have pretty much the same sequence in the sense that the difference from term to term is also the number 2. 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, etc. The only difference of this sequence with respect to this one is that this is an infinite sequence. The number of terms are endless. Well, the number of terms is endless. It goes on forever. Okay, so in this case, you must acknowledge that it would not make any sense to ask for the series of the sequence, right? If somebody asked me, what is the series for this particular sequence? I'm gonna be like, well, I don't know, because it's endless. So in order to perform this series, what I would have to do is add 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus up until infinity, and I would never ever end. Okay, I would never finish. So asking for the series of an infinite sequence does not make sense, at least not yet, not at this point. A little later, I'm gonna convince you that in some specific cases of infinite sequences, we can find the series, but not yet. We don't know about that stuff yet. Okay, so what then? Do we just leave this question unresolved, or can we change it a little bit? For example, what if I tell this person that is asking me for the series of this sequence? What if I tell her, you know what, I cannot give you the full series of the sequence, but I can give you the series for just a number of terms that you want about the sequence, right? It's an infinite number of terms, so just give me or tell me how many terms do you want me to add up in regards to the sequence. For example, she may tell me, okay, add up all the terms up until the 5th term. So what is the 5th term? The fifth term is going to be 10. And I can do that very well because it's just a finite number of terms. 2 plus 4 plus 6 plus 8 plus 10. And when that happens, guys, when you just want to get the series for a particular number of terms of a sequence, what you do is you write the symbol. You're going to write S, and then you're going to write the number of terms that you are adding. Since I want to just add the first 5 terms of this infinite sequence, I'm going to write S 5 or S sub 5. And what this means is the series for the first 5 terms of this infinite sequence. And since we already got the first 4, which is the series is 20, then for the first 5, we're gonna get 25. So how do we read this? We read the following. The series of the first 5 terms of this particular infinite sequence is equal to 25. That's what this symbology means. S and then a little number as a sub-index. It's just the number of terms that you are adding from beginning up until that term. First term, second term, third, fourth, and fifth term. There you go. Let's see another example. This one. What type of sequence is this? It's an arithmetic sequence because it goes by jumps of 3, minus 2 plus 3, 1, 1 plus 3, 4, etc. It's a finite sequence, okay, because it ends. You have the point here. It doesn't go on forever. And again, I can get the series for this sequence. Now, I can also do the same thing I did in here. I can get the whole series if I want it. Like the whole series, just the S means all of the terms that comprise the sequence, all of them. But I can also do this, just a small number of them. Maybe I can just, I want just to find the sum of the first 3 terms. So I would write this, S3. And what this means is the sum of the first 3 terms of this particular sequence, which happens to be a finite sequence. So S sub 3, what would that be? That would be minus 2 plus 1 plus 4. And that gives me a total of 3. There you go. So we can also get a definite amount of terms in the series, even for finite sequences. It doesn't have to be the sum of them all, not always. Okay, look at this one. This is another sequence by jumps of 1. The difference is 1. It's an infinite sequence, and in this case, I want the sum of the first 7 terms. The series of the first 7 terms for this particular sequence. Okay, I give you some seconds. Get me that series, guys. What would be the sum of the first 7 numbers? Do it on your own. It's gonna be 28. Okay, S sub 7. Well, let me actually write that down. The whole series, that would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, because this is the 7th term, and it stops right there, and you will get a total of 28. So there you go. This is the series of the first 7 terms of this infinite sequence. Fine. So that's what this series is, guys. Do not confuse series, which implies performing a sum and addition of terms, with the word sequence, which is just the list of numbers, just like we saw last class. These things are not the same. They're not the same, and they very often get confused. They're not the same. Okay, fine. Let's continue. Now that we know what the series is, the series for a sequence or the series of a sequence, how do we find the series for the first n terms of a sequence in a quick way? Okay, that's what I'm trying to get. Quick way. Because yeah, I mean we can do this by hand and sum number by number, but in most cases that's complicated. You can make mistakes, and when the number of terms that you want to add is very large, this gets very complicated, right? For example, imagine that for this sequence, I ask you not for S5, but what if I ask you for, I don't know, let's say S1023. Okay, what's the series of the first 1023 terms for this particular sequence? you're not gonna do that by hand. It's gonna take you a lot of time, and probably you're gonna make a mistake. So can we come up with a formula to do this very quick, to do this calculation very quick? The answer is yes. And that's what we're gonna do right now. Okay, so this formula, guys, the deduction for this formula uses a trick, a very clever trick, which is the following. I'm gonna write this finite sequence. There you go, 2, 4, 6, 8. The difference is 2. And I'm gonna write the same sequence, but in different order from the last one to the first one, or in other words, in reverse order, and right below it, like so. Okay, same sequence but in different order. And what that means is that basically they are different sequences, right? Because we said that the order is important. So this sequence is not the same as this. It has the same elements, but technically, since the order is different, these two sequences are different. But I don't want you to pay attention to that fact. I want you to pay attention to the fact of this. If you did this trick, if you write a sequence and then write the same sequence in reverse order, what you're gonna find if you add column by column the terms, for example, 2 plus 8, and then 4 plus 4, and then I made a mistake in here. It's gonna be 8, 6, 4, 2. Sorry about that. So if you add 2 plus 8, you're gonna get 10. If you add 4 plus 6, you're gonna get 10. 6 plus 4, you're gonna get 10. And 8 plus 2, and you're gonna get 10. And this will happen with any other sequence. It doesn't make any difference. Whatever sequence you choose, if you put it in one direction and you put it again in the opposite direction, and you add column by column its terms, you're gonna get the same results in here. That will always happen, always. So we're gonna use this trick, or this happenstance, this idea, in order to derive the formula that we want to get. So here we go, guys. This is where you start to do real mathematics. It's very fun. Okay, guys, so let me write any sequence in general terms. So any sequence, as we know, is made up of a first term, u1, that's the first term of a sequence, of our sequence, and then comma, second term, represented by u2, and then the third term, and then many other terms, up until the following, an nth term. So I'm writing a sequence of n terms, a sequence in abstract terms. I'm not telling you what specific values these terms have. I'm just writing down first term u1, second term u2, third term u3, etc., etc. We have many more terms in here hidden, and then the term n minus 1, because that's the one that goes previously than this one, right? And then finally the nth term of this sequence, the nth term represented by un. So I'm just gonna leave it there, period. There you go. Now, if I want to add this, all of these terms, what I'm gonna get is the series for the first n terms of this sequence, right? Because you can imagine that this goes on and on forever. It doesn't stop right here, but it can go on forever in the case of infinite sequences. So what if I just want to add the first n terms, this one plus this plus all of this inside plus this of this sequence? Then what I want is the series of the first n terms of this sequence. And let me write that down in this way. I'm gonna just express it. u1 plus u2 plus u3 plus etc. plus un minus 1 plus un. There you go. This is my whole sum of the first n terms of this sequence. It's all of this. I'm just expressing what I'm about to do. Period. Okay. And then I'm going to use the same trick that I showed you in a moment. Look, I'm going to write this. I'm going to choose all of this chain of additions, okay? And I'm going to reverse it. And I'm going to write it down here below this one. I'm going to write first un plus un minus 1 plus un minus 2 plus etc. up until plus u2 plus u1, the first term. So basically, guys, I wrote the same thing, this same expression in here below in reverse order. That's all I did. You see, it's like writing this 1 plus 2 plus 3 and then 3 plus 2 plus 1 below. That's all I did, guys. Now, since this is the same as this, right? Then I can write also, and if I already represented all of this by s sub n, I can do the same for this thing, right? This is going to be equal to s sub n, which I repeat is the sum of the first n terms of this particular sequence. Okay, guys. Now here's the trick. What we do, what some person discovered a lot of years ago was this. He thought, what's going to happen if we add these two equations, okay? Because we have one equation and another equation. What's going to happen if we add them column by column? Okay, what's going to happen if I add this plus this? Can we do that? Yes, of course, because whenever you have two equations, guys, a equals b and c equals d, you have two equations, right? And you can always add side by side both equations. You can always say, okay, then a plus c, which is these two added together, will be equal to b plus d. That makes sense. Okay, and I'm going to do that in here. I'm going to do the same in here. I'm going to add this term with this term, and I'm going to put it here. That's going to be equal to 2sn, right? If I add sn plus sn, I get 2sn. Fine. Equals this plus this. So I'm just going to represent it in this way, and I'm going to put a parenthesis in there. u1 plus un. There you go. And then plus the addition of these two now. That's going to be u2 plus un minus 1. And then plus the addition of these two. So that's going to be u3 plus un minus 2. And then plus, we keep doing the same process. And then plus un minus 1 plus u2. And finally, we get 2u1 plus un, or un plus u1. Okay, now this may look complicated for you. I understand that, but bear with me, guys. Okay, now, what did I say just a few minutes ago, guys? I said, if you have a sequence and you write it down, and you have the same sequence and you write it down below in reverse order, when you add the terms column by column, you will always get the same number. 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4, etc. That happens for any other sequence, no matter how complex. Now, you must realize that we did the same in here. We had, well, in this case, the series for this particular sequence, and then we reversed the series, you see, from u1 to un, and now from un all the way down to u1. So when I add these two terms, I get this. When I add these two terms, I get this. These two, I get this. These two, I get this. These two, I get this. And all of the couples in between, which should be here. Now, the important concept, guys, is this. You must realize that all of these couples of additions, whatever I have in here, and whatever I have in here, and whatever this is in the end, this addition, and this addition, and this addition, are all the same. This is the same as this, which is the same as this, which is the same as all of these things inside, and this, just like we found in here. Can you see? This is the same as this, which is the same as this, etc. So all of these parentheses, guys, what is inside them is the same value. This is the same as this, the same as this, the same as this, the same as this. All of these things are the same value. They are all worth the same value. Okay? Now, how many couples? Okay, now, if they are all the same, I can do this. I can write 2Sn equals, I can represent them by just this. Look, U1 plus UN plus, I'm gonna stop writing this addition in this way. I'm just gonna call it U1 plus UN again. Why? Because all of this is the same as this. And if this is U1 plus UN, I may call this the same as this, right? And the same for the others, because they are all the same. It doesn't matter. Can you see? All of these things are equal to U1 plus UN. All of them. And well, this was already established, right? Okay. Now, what is the last step of this maybe complex deduction? It's the following, guys. You have how many couples of the same thing in here? In this part of the equation, in this right part, how many of these do you have? How many parentheses, so to speak? And don't say 5, because you see 5. 1, 2, 3, 4, 5. But you cannot ignore all the ones that are right here. So how many of these do we have? Well, we have as many as there are terms in the sequence, right? Look, we have 1, 2, 3, etc. up until n. We have n terms. And each of these terms produced, when coupled with the one below, produced each of these couples of additions. You see? So how many couples of these do we have? We have 1, 2, 3, etc., etc., etc. N minus 1, n. We have n couples all equal to U1 plus UN. In other words, we have 5 expressions all equal to U1 plus UN. N couples. There are n couples in here, guys. I'm gonna write down here, n. Okay, and the last step, in order to finish this process, I hope it fits right here, is writing the following. We're gonna write 2Sn equals, what happens when you have n, when you are adding n things, all of which are equal to, in this case, U1 plus UN. For example, what happens when you have, let's say, 3 plus 3 plus, etc., plus 3, and I tell you, you have 10 of these, 10 threes. How can you express this with a mathematical operation? That's going to be equal to the thing that you're adding, which is the same over and over again, times the number of things that you have. 3 times 10, right? That's going to be 30. So in other words, is the expression that you are adding, in this case 3, times the number of expressions that you have, which in this case is 10. And it's going to work the same way in here. I have n expressions all equal to these parentheses. Therefore, this is expressible as n times U1 plus UN. You see, all of this stuff boils down to this, n times U1 plus UN. And finally, now this is, I forgot this, there was one more step. Finally, I'm going to write this in blue. The final step, which I'm going to conclude over here. Let me write down what I just have. 2Sn equals n times U1 plus UN. The final step, in order to get the formula, is this. We're going to divide both sides over 2. If I do that, I'm going to get Sn equals n times u1 plus un over 2. And there you go, guys. You see, this is a formula to get the sum of the first n terms of any sequence. What do you need? Well, you need n. You're going to put it there. You're going to need the first term, and you're going to need the nth term. And with those three things, you do this operation, and you can get this value very quickly. And I'm going to show you some examples of this in a moment live with you. So uh, tell me what you thought of this process, guys. Was it difficult? Was it simple? Did you get it? Did you not get it? I want some feedback. I know it's a little complex at first. I want you to develop the whole thing on your own later, like do it completely on your own, as if you were explaining it to somebody else, and see if you can get to the same formula, and see if you can understand each of these steps. They're not really complicated, okay? In my opinion. Okay, guys, let's stop right here, and let me go back with you.